So let's start with discussion of fixed effect model. So I'm not someone stop recording for. So I'm starting with the fixed effect regression model. Not going to cover pooled and fixed effect least square dummy variable regression model today. Because generally when you work with the regression model, either we work with the fixed effect regression model or with the random effect regression model, depending upon uh, uh, appropriate choice of our model. So, and how do we make a choice? For for that, we rely on Houseman test, and if Houseman test suggests us to go for random effect model, then you give an thought to whether data with which you are working are randomly drawn from a large population. If it is so, then we go ahead with the random effect model. Otherwise, we work with the fixed effect model only. So for running a fixed effect model, is okay. Let me. I haven't started sharing the screen, so let me do that first. Okay, done. I hope you can see the screen. So this one is a stata screen. So for a fixed effect random, for a fixed effect model, the command is this one. So xt regress, then dependent variable, all independent variable, and fe. So when I enter, we get fixed effect regression result. You have already done with the interpretation of fixed effect regression result. So I'm not going into that. Of course, after then we run a random effect model, and you have to make a choice between these two models. For that, we run a Houseman test commands. So, so what we do for that? First, we run fixed effect model, save the result of fixed effect model, then run random effect model, save the result of that, and then write Houseman command. So the command for that is this one. So this one is a fixed effect model. Run this one. Save the estimates of the fixed effect. Estimate is stored fixed. I'm repeating this one. Then after we run random effect model, we save the result of this. And after the we do Houseman test. So HUS Houseman fix random, and then type sigma mode. So now we have gotten the Houseman test statistics associated chi-square value and p-value of chi-square test. So p-value is here 0.00. We reject the null hypothesis, and null hypothesis is there is no systematic difference between parameter estimated from fixed effect model and random effect model. So here Hausman test suggests us to go with the fixed effect model. So there is no need to inquire more about the random effect model. Straight away go with the fixed effect model. And there is another reason also for going with the fixed effect model, because you are working with a country level of data, and we know, and here we have included almost all country in the world, and we know that the country are heterogeneous, and in that case obviously our best choice would be fixed effect model, and the same is suggested by the Hausman test also. So we go with the fixed effect model. Now let's suppose that the Hausman test suggests us to go with the random effect model. So as I told you, Hausman test is not a sufficient test. It just tells that there is no systematic difference between parameter estimated from fixed and random effect model. That doesn't mean the random effect one is more suited as compared to the fixed effect model. So once the Hausman says suggest us to go with the random effect model, we start inquiring more about the data. And if we believe that the data is randomly drawn from a large population, then we can go ahead with the random effect model. Randomly drawn from a large population, let's suppose that you are working with the district level of data. In India, you are having a, how many districts you are having in India? 700? Any idea? Hello?
Sir, about 740.
About
Google says
740.
yes.
Yeah, 740. So let's suppose that you are having a 740 40 district in India. Okay? And let's suppose that you are working on something which requires district level of data, and you do not have a all district level of data of that particular variable. So even though your data is not a random data set, but it's become random just because of availability of the data set. So out of 700, let's suppose that you are having only 200 data set, okay, and 200 district data set, and the districts are scattered over India. So if random effect suggests us to go with, sorry, if Hausman test suggests us to go with the random effect, and and if you believe that by sampling or by data generation process, your data become a random data set because it is coming out of a large population. It is coming out of 700 districts. So in that case, you may go ahead with the random effect. But once you make a choice of random effect, let's suppose that you are going to work with the random effect. Okay. So after then, we have to compare the presence of random effect in the model. And for that, I think we have discussed a test that called the Lagrange multiplier test. So we check the presence of random effect. If there is a presence of random effect, sorry, that one is the Bush-Pagan Lagrange multiplier test. So we run random effect model, check the presence of Bush-Pagan Lagrange, check the presence of random effect. So let me do that. So I'm running a random effect model here just to show you the result of that test. We did this one last time also. And then after, suppose that we made a choice to go ahead with the random effect model. In that case, we do this test. Otherwise, if your choice to go with the fixed effect model, then there is no need to do this particular test. So XT test 0 is saying that XT test is 0 is unrecognized command, so probably it has not been installed on this uh, Stata software. But today I'm working with the Stata 14. So we need to install this one. And for installing, either you go with the SSC install command, SSC install XT test 0. Say that XT test 0 not found as SSC. Okay, so let's go type this one, find it X test 0. I made a mistake. This one is XT test 0. This one is the result. So here null hypothesis is rejected, and it's so that there is a no random effect. So in a case when your choice is random effect, and after then we do this test, and if test is rejected, you may use pooled regression model. So in that case, pooled also give you consistent and efficient estimates of parameter. If there is a presence of random effect, then random effect one is best model. So this way we can make a choice between random effect model and pooled effect model. But our data set suggests us to go with the fixed effect model. So go ahead with that. So once we have decided to go ahead with a particular model, we do diagnosis testing. And in a diagnosis testing, we check for heterozygosity, we check for autocorrelation, we check for contemporaneous autocorrelation. Checking whether time effect is not that we can do even before and after running first effect regression model. So if there is a time effect, you must include time damage into a regression model. Then after you do all diagnosis testing. So it would be always better to work with the full model instead of working with the half model. That's why I am saying. So, and for time effect, test farm one is the command that we have discussed yesterday. So you use that for taking time effect. Now let's do testing heterozygosity, because we know there is no time effect. So I'm not going to include the time damage. So next one is for testing heterozygosity. So after running a fixed effect model, but this one is appropriate model, we do test for heterozygosity, and command for heterozygosity test one is xt test 3. So null hypothesis is no heterozygosity, result coming at p value 0.00. So we reject null hypothesis. That means there is a heterozygosity problem with our model. Similarly, we check for autocorrelation, and command for the autocorrelation one is xt serial, then dependent variable and independent variable. These all commands are given in Cameron interview. So this one, so this gives us test for autocorrelation, first order autocorrelation. So null hypothesis is rejected here. That means there is a autocorrelation problem. To know more about the autocorrelation, we just type or more about this Ulrich test for autocorrelation. We just type xt serial. This document open, and though it is short, so you read it. For more detail, type onto Google xt serial. So you will get a Stata Journal article which deals with the xt serial command, and there you will get a detail of this particular command. So this one is for serial correlation. Now we are going on to the move onto contemporaneous autocorrelation. So last time we run this particular command xt psd psara abs. The last statement not xtrd, so let's do first that fixed effect regression model, and then type this one xtcst option psaran abs. Okay. And again you are getting a similar result what we have gotten last time, and this time again p value, pr value which I am reading as a probability value is 0.196. Test statistics is minus 2.119, and absolute value of all diagonal element 1 is 0.419. So last time I was suggesting us since our data set contains outlier, so might removing outlier help us for getting a better statistics. Okay, so of course when you remove outlier, statistics become better. Okay, but the problem of getting PR 1.96 persist. So what happens? So this particular data set do not contain any outliers. I remove all those outliers. After removing, I made data set as balance panel data set, and you are working with the data which have no outlier, and also have a balance panel data set, and also having a characteristics of short panel data set. So, but still you are getting 1.9659. So, I have gone through the I have gone through the reading on this particular test. Also, I Google this one. We are getting probability value as like this, which one is the greater than 1. Okay. So there is no direct answer of it. There is some discussion on Stata blog regarding it, and even there uh, uh, they haven't come with an exact answer of it. But instead of running this particular test in such a way, they have suggested to run the same test in a different way, or in that case, we are getting a probability value less than 1. And when I was going through the literature, I found that for a cross-sectional data set, Psaran test is not only a test, there are two more tests. One is called Friedman cross-sectional dependent test, and the other one is Frisch cross-sectional dependent test. And going through this data journal, which deals with the XTCSD command, I found that in that journal, author suggested to run all these three commands, especially when we get a either we get a contradicting result. Even that article uh, haven't talked about this probability value greater than 1, but that articles uh, deals with the what we do when we get a contradictory result when we use all these three tests. That means Pisaran cross sectional dependent test, Friedman cross sectional dependent test, and Friese cross sectional dependent test. Okay, I'm coming on to this. So Anushka asking, sir, what are the name of this test? So the one test is called the Pisaran test. Second one is Friedman, and the third one is Friese, Frees. So we run all these tests. So this one is the Pisaran test. The alternative way of running Pisaran test, okay, though I have to read more of uh, onto that, but that one is XT,
Sir,
CD, yes,
sir, how do we interpret this XT-CST test?
okay. Uh, the result which what is displaying before us, in that case, uh, we are getting PR value greater than 1. So let's read that one as uh, uh, take inferences out of that. We are accepting null hypothesis. So this one is the acceptance of null hypothesis. And once we read this one, average absolute value of of diagonal element, which one is 0.419. So it shows us there is substantial uh, dependence between cross-sectional error term.
Okay, sir.
Okay, so that's why so the null hypothesis one is as usual there is no cross-sectional dependence. So only when we reject your null hypothesis we can say that there is a cross-sectional dependence. Fortunately, it suggests us there is no cross-sectional dependence. So if let's suppose that if you go without ABS, then we get first result only, not the second one. So, uh, and the purpose of getting this average absolute value of off diagonal element, let's suppose that I'm going to show you another result, which I am typing. This one is so. So this one is the cross-sectional, correlation matrix of residuals, estimated residuals after running a fixed effect model. So these are the off diagonal term. So when we add all these off diagonal term, so in this we can see the some are positive, some are negative, okay, and many value we see as a negative value. So I think adding all these cross off diagonal terms, giving us that value 0.416. But I found in a literature if there is more positive and negative value, so they counterbalance each other, and in that case we may get inappropriate value of uh, Pisaran test statistics. Okay. So that means if you go with that test, then we may accept our null hypothesis, okay, and we may accept our null hypothesis, but the actual situation is that there is a substantial cross-sectional dependence between error terms. So that's why the author suggested us to do all these three tests for cross-sectional dependent test. So let's do that. So here, and with this particular result, P-SARAN test suggests us that there is no cross-sectional dependence between error terms. So the another command one is this one, cxt freeze frees, and when we type this one, so it takes some time. Anushka have written, I was asking about the test to check random effect. That one is the Bruce Pagan Lagrange multiplier test. Okay, so the result has come. So again here the cross-sectional dependence is coming out here 23.273. Critical values from freeze Q distribution is given here for a different level of significance. And when we compare this Q distribution's critical value with the test statistics, then we accept our null hypothesis. So that means there is no cross-sectional dependence between error terms. So that's what freeze statistics suggests. Let's do a Friedman statistics test also. So this one is the Friedman xt csd comma Friedman, and when we run this particular command, it also takes some time. So, so the probability value is in this case is exactly 1, and cross-sectional dependency statistics, if it Friedman test statistics is 13.847. So again, in this case, we accept our null hypothesis. That means all these three tests, Friedman, Freeze, and Pisarans, giving us same result. So we can conclude here there is no cross-sectional dependence between the error term. No, something. Okay, sorry. Let me check the null hypothesis first. The null hypothesis is no cross-sectional dependence, right? Okay. So null hypothesis is no cross-sectional dependence. So we are accepting null hypothesis. That means error terms across cross-sectional units are not related with one another. The other way of doing PSRN test one is after running fixed effect model, we predict residuals with this command. So I already predicted these residuals, and after having these residuals, we run this command xtcd residuals. And look here, this command again give us Pisaran test statistics. Which one is now here 1.77, p value is 0.0776. So again it is greater than 0.05, so we accept our null hypothesis. And null hypothesis cross sectional independence. Why I confused? I think we have to check the null hypothesis again. So give me a okay. So null hypothesis is no cross sectional dependence. So we are accepting that. That means that there is no correlation, cross sectional correlations between error terms. So, so any confusion? And there is a one more test for it that we do in case of uh, large panel. That also called a Lagrange multiplier test. So when you are having a large panel, that means t greater than n. So we use that command, and command is xt test2. So xt test2. This one is the command. You just remember when we work with the long panel, we use this particular command for uh, cross sectional dependent test. More about this test we get from the Stata Journal article. So just type on the Google XTCD Pisaran Stata Journal. You will get a link of that. That one is freely downloadable. Go with that. Whatever I have discussed regarding this cross-sectional dependent test, everything is given there. And that would be, and that article would be very much helpful for building understanding on this contemporaneous correlation. Because if there is a presence of contemporaneous correlations and we go without taking care of that, in that case we get biased and inconsistent result. So that's why taking care of this particular problem is very important. You must do a testing for it in a panel data regression case. And if there is a presence of contemporaneous autocorrelation, so let's suppose that in our case there is no presence of contemporaneous autocorrelation because you are accepting null hypothesis. But if there is, then let's then In that case, our regression model suffers with the problem of heteroscedasticity, autocorrelation, and contemporaneous autocorrelation. So given that we use XT-SCC command, ln total serial, ln GDP, fixed effect. So this particular command take care of autocorrelation, heteroscedasticity, contemporaneous autocorrelation. So this one is the end result. You will use this result for making inferences. Since, since actually our regression model is not suffering with the problem of contemporaneous autocorrelation, so you may go ahead with the other solution of heteroscedasticity and autocorrelation problem. So even you use GLS or FGLS that take care of heteroscedasticity and autocorrelation problem. So you may use that. So when I was presenting the things, I presented a table which deals with the different command in a case of different type of in case of different types of problem. So you can use that for running a final regression model. So that's much for the basic panel data regression model. I'm going to stop here, and after then you are going to move on to the dynamic panel data regression model. Now time is 3:13. So do you need a break or want to continue? Okay, so there are some query on the chat box. And yes, you are asking what happened when you use fixed effect model instead of random effect model. In case of no heterogeneity between cross-sectional unit, will there be any consequences? Yes, Ananya. When random effect model one is appropriate model and we use fixed effect model, in that case we get inefficient estimates of parameter. So there is a compromise of efficiency of parameter. And then I want to speak.
No, sir. I was just asking this only. You just answered it. Thank you.
Okay, so asking sir can't see message. I think which message?
Sir, I was just telling Ananya when she was.
Okay, you need to use my.
Yeah.
By asking for break, sir, 5-minute break. Okay, let's take a 5-minute break. Not 5 minutes. Let's take a 10-minute break. 5 minutes is too less. So 15:15. So we'll meet at 15:25. Okay.
Sir, you can stop the recording and then start it again.
Okay. So thank you for this. So I stopped recording.